Hey everybody, this is Larry. This is day 11 of the April Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, the contest, whatever's on your mind. Today's problem is the deepest leaves sum. Given the root of the binary tree, return the sum of the values of its deepest leaves. Okay. So in this case, is it just 7, 5, and 8? Okay. And I don't know what this shows, but okay. Yeah, so I usually solve these live, so if it's a little bit slow, fast forward or watch it on 2x or watch another video. That's what I always say because people can always complain that I am slow sometimes. But that's how I'm going to solve it live. But yeah, for this one, the intuition is just going, you could do a breadth first search or depth first search. It doesn't really matter. In order or whatever. All you have to do is just you have to visit every node in the tree, so it's going to be linear time, and as long as you do that, it's probably okay. And then the other thing that you have to do is just check that it is a leaf, and if it is a leaf, then you add it to the sum. There are a couple of ways to do this, taking advantage of pseudo global variables, or you can just have the function return it itself. In this case, I'm going to do it the latter way, where we return the function where it gives us the sum of the leaves. So yeah, so let's go deepest. We have a node. We have a node. If node is none, we return 0. Okay, and then now if node dot left is none and node dot right is none, then this is a leaf. This is a leaf. So then we return node dot value. Otherwise, we return the deepest of node dot left plus the deepest of node dot right. And I think that should be good. Dong dong dong. Yeah, I mean we have to return the deepest of the root, and that should be okay because now we have the base case. We go recursion on the left and we get on the right, and we sum it all up. So let's give it some testing love. Feel like I've been very sloppy lately, and again, this is also true here because because I'm getting the wrong answers. Why am I getting 15? So let's see. Print node.value. So we're only looking at the leaves. Which ones are the leaves? Well, we have two inputs here, so that's a little bit awkward. Let's remove one of them. 7, 5, and 8. So why does this return 20? Dun dun dun. Usually, yes, we're mostly right, just not actually right, which is not as good. That's weird. I probably have some assumption because usually, like I said, I would have a global variable, and then here I would just add this to the global thing. And in this case, that would be right because, but now I'm trying to debug why this is not good enough. That is a little awkward. Yeah, so what does this tree look like? So the 4 should have a 7, the 2 should have 12, and the 1 should have the 12, 20. Oh, wait. Maybe I misunderstood this one, actually. I did the math wrong. I did 7 plus 8 and 5, and I said it was 15, but actually that's wrong. So what is the deepest leaves, not just the leaves. So, okay. So we have to make some modification, but that's okay. They really should define what deepest mean because I think I wasn't quite sure when I read it and it just didn't tick. But that's fine. We just have to make quick modification. And I don't know. To be honest, I've been misreading prompts a lot lately. So this has been a little bit of a sad moment because this is a misread as well. It's just that the test cases correctly tells me I'm wrong. So basically here, let's see. I don't know. I think this can definitely be done with this kind of notation. So let's do it. Let's add a level as the thing that we track, and let's just start at 0. We return 0, 0 say, or 0 at 0 at -1 maybe. And then here we return node.value at a level. This is a little bit wonky now, but then basically now we have to keep track of this stuff for the other case, which is left, and then right is here. And then we have to do some tie breaking things, and that's where it gets a little bit messy. Again, I think if I was in a contest, I would just abuse the global a little bit and just be like, oh, just increment it if it's equal to low level. But in this case, let's go it through. If the level, this is the level, which is is equal to the right dot level, then we return node, return nodes up. Oops. And then just so this returns the sum of them. If they're on the same level, we return the sum and also the level of one of them. It doesn't matter which one because they're the same, right? And then else if left of 1, if that means that the left is deeper. If the left is deeper, we just return left, else we return right. Hopefully this should be right. Oh, well, it's not right because we have to get rid of the levels on this part, but that's okay. And also we forgot to do, and I say we even though only I did this, but yeah. Cool, looks okay. Am I Gucci? Am I good? Yeah, let's give it a submit. I'm a little bit lazy today. It's 3 a.m. I've been lazy lately in general. But okay, so looks good. Yeah, so this is how I would do it, doing recursively without using any global variables, because I think that's how I've been teaching that a bit, because this requires a little bit more thought. But this is definitely the way to stay clean. And what's the complexity of this? Well, each node will be looked at once, and yeah, and this is just a standard pre-order, or depending on how you want to define it, pre-order or something like that. Or I guess we never look at this node, so it's just a traversal. So yeah, so linear time and linear space, or h space, where h is the height of the tree, and that's it. And of course, the other way that you could have done it is just have like a best answer. Is you go to say 0, -1. Here, another way to do it would have been this, which is what I'm talking about, the global. I don't know that I recommend it, so definitely go back and take a screenshot of that if you like. But yeah, I will return best of 0. But then here now we can go, yeah, we can just do this way quickly. But it's the same idea, which is that if left of 1 is greater than best of 1, then then best is equal to left. Else if left of 1 is equal to best of 1, then best of 0, something like that. This is not quite right because that's not a notation in tuples, so you actually want to do something like this. Again, this is the same idea over there. Basically, we're just merging these two, and maybe we'll have a helper function as well. But yeah, let's just do a change max or something like that, or maybe merge. That would have been a little bit cleaner. Current, and that's just basically this thing, right? Yeah. And then now you can also merge right, and then you don't have to return anything. Actually, yeah, you don't have to return anything. There's no returning anywhere. Actually, yeah, why did I do it this way? Now that I think about it, actually, this is a bit wrong. All you have to do is just go, yeah, merge node.value level, and that's pretty much it. Actually, I forgot that was my original intent because I was mentioning earlier. But yeah, and then just do the regular recursion, and that's how you would. That's roughly how. Hope this is right because that'll be embarrassing if it's not. Ooh. I forget to have to do non-local. Which is a smell in general. Oh yeah, because now this is not a thing. So if I wrote it fresh, I usually get it right, but you know, there's a lot of copy and paste essentially by manipulating the right code. But yeah, 1519. So yeah, so that's how I would do it with the global, which is maybe cleaner depending on who you asked, but the idea is basically the same rough idea. Yeah. Again, it's going to have the same complexity because everything is the same. It's just taking abuse of this non-local thing and scope the variables. But yeah, that's all I have. Hope y'all have a great day. Have a great weekend. I'll see you later. Take care of yourself and, you know, to good mental health. Bye-bye.